This is going to be more of a masterclass on bash scripting rather than a small lecture. And we're basically going to learn how to create scripts out of commands that we already saw and we're going to see throughout the series of lectures. And we're going to start with bash. And bash is the bourne against shell, and it's the command line interpreter that we've been using. It's the default shell on most Linux systems. It supports a scripting language, and it was released originally in '89. And why do we want to learn bash scripting? Well, because we want to automate repetitive tasks. It's fundamental for system administration, quick prototyping. It's available everywhere, and it's extremely powerful for file and text processing. So, what's the difference between a shell and a script? The shell, it's of course interactive. Here I got my shell open on my machine. I'm in my home folder, and it's good for exploration. While scripts, it's a series of commands in a file that's reusable and repeatable, can include logic and loops, and they can be run within bash, within the shell. So let's take a look at a script. So let's create a script.sh. This is the common extension for bash scripts. And let's make this script executable. Let's start editing the script with Vim. And the first thing we want to add is a shebang, it's called. And it basically instructs the opening shell on which shell the script should be run. So suppose we are running this script with a shell that is not bash, the shebang is going to inform that other shell to use bash to run the rest of the script. And shebang is this dash exclamation dot sequence followed by the shell that we want to use. We got comments, so this is a comment, so it's going to be ignored by the shell that is executing the script. And now we can just type commands. For example, hello world. Now we can execute the script with /script. And here we have the hello world. Now, if we want to make this script available as a system-wide command, we need to move that script inside a folder that is currently inside our path directory. And this is either going to be home marco.local/bin, home marco bin, user local bin, user bin, user local sbin, and user sbin. So let's, for example, create this home marco bin, mkdir bin. Let's move script.sh into bin. Now we should be able to run script.sh without the / because that folder that we just created, it's already inside the path, and that path environmental variable instructs the shell on where to look for commands inside the system. Now let's start editing a little bit this script file, and we can start dealing with variables. Now, for example, we can have my var with 42, no spaces, and we can type the content of my var with $, my var. We can run the script, and here is the output of my var. So this is how we deal with variables. And we can unset a variable with this one, and if we print it again, it's empty because it doesn't exist anymore. We got a few special variables in bash, and for example, if we try and print argument 0 is $1 and all arguments are at and echo number of arguments is we can script at that stage with arg1 and arg2, and argument 0 is always the name of the executable. Argument 1 is the first argument, and here we have 2 arguments and the number of argument is 2. So here we should be like this. Here we got argument. Here we got argument 1, argument 2. All arguments are arg1, arg2, and we got 2 arguments on top of the script name, which is on $0. We can also get the PID of the current shell instance that is executing the script with $, and this is the output that we have. Now, if we want to know the exit status of the previous command that we executed, we can type $, and if we get 0, it means success. Any exit code other than 0 means failure, and the particular exit code is indicative of why it failed, typically. Now, if we want to substitute the content of a string with the output of a command, we can use, for example, today's date is $, open parentheses, name of the command. And if we execute this, today's date is the output of date command. Now, suppose that we want to read user input. What we can do is, for example, echo, enter a number, and we can read and save that interaction inside a my_num variable. Then we can echo the inserted number is $my_num. Let's, for example, put 12. The inserted number is 12. And here we have also the example if we want to input passwords with all the asterisks to hide the whatever we're typing. We can also prompt onto the same line it read -p string that we want to show and name of the variable where we want to store that input data. Well, let's put 12, and here's the inserted number is 12. And we have also timeouts and whatnot. Now, we can start to get creative with the bash scripting, and we can basically start implementing a if statements. Now, let's the user insert a number, and let's see if the number is greater than 10, then, and here is extremely important, the spaces and square brackets, the comma and whatnot. And is greater than 10. Number is greater than 10. We can also have an else statement here. Number is smaller or equal than 10. Let's remember to close. They are the operands that we have: greater than, equal, greater or equal. And so here can remove that. And for now, number is greater or equal than, and the same thing goes. We got less than, which is LT, and LE less than equal. So this is the comparisons inside an if statement between two numbers. And here we got all the test operators for equal, not equal, greater than, greater or equal, less than equal. We can also go with plain arithmetic signs with the double parentheses. We can use what we're used to from other languages like C, for example, without having to use the test operators on numbers. Now on string, we can do insert string 1, my string 1, insert string 2, my string 2, and we can test those strings are equal. Here we're using the arithmetic. We need the double equal signs. If we're not using arithmetic but square brackets, we can use just one. Strings are equal. Strings are not equal. Now, if we want to add some more checks here, you can do if the string is empty, and if we print the previous exit code is 255, which is -1 if we consider an 8-bit return value. So the return value is pulled into a byte. -1 is 255 into complement. And in fact, if we now send the second string empty, we should see 254. And that's how it is, because on an 8-bit boundary, -2 is 254 into its complement. Now we can also test files with -e, -f, -d to check if it's a directory, -r, w, and x to check for permissions on the current user, and -s to check if it's not empty. In here we got logical operators. We can chain if statements within the same control sequence if we want to perform more complex operations. So let's go to script.sh and let's combine these two. Suppose that we want to exit if any of the two strings it's empty. We can use the OR operator, -t, $my string 2, and 1. Here we can write one of the string it's empty. Can't remove this one. Boo. One of the strings is empty. And we exit with -1. And we can also use the AND operator with double AND and the NOT operator with an exclamation mark in front of the condition that we want to check. We also have case statements. And here it's interesting to see how a case statement works. We check if that was perfect. Now let's implement the case statement. What the case statement does is case $mynum, so the variable that we want to check in, and all the options that we have. And we can also remove this thing and insert a default statement here that says we exit with -1. So this is what we call a default statement that matches all the other options that are not explicitly listed here. We can also have for loops, and here let's create another script. Let's call it loop.sh. Let's put a shebang here. For I in 1, 2, 3, do echo I is $I. Done. You can also use C-style for loops with for I equals 0, I less than 10, I plus plus, do echo I is $I. Done. And here we have the result. And we can also insert output commands inside the conditions that we want to check. So for example, here, if we insert the for user in $cat, you see, it has BD. Cat D and F1 do echo user done. We're basically printing all the users that are available in our system that are registered in the etc SVD file. The same thing goes for while loops. A while loop is a loop that has a condition that, as long as it's true, we are going to execute a loop. So if we have a count equal 0 and while count is less than 5, do echo and this basically looks like a while, a for loop. We get the opposite of the while, which is the until loop. You can experiment with that. It's basically the same thing. That loop executes until that condition is true. For loops, we do have break and continue. So suppose that we want to execute a for loop until we find the first hit in a file, and then we don't care about what happens next. We can break the for loop there. Or if we want to ignore certain occurrences on a for loop, we can implement a continue function that basically skips that iteration of for loop. Now we can start playing with this thing and extending it with functions. So let's call it functions.sh. And here we can say, can define here we can define a function, for example, like hello world that doesn't take any parameter and prints echo hello world. In here we just call function. If you want to pass a parameter, to do so same way that we do with accessing arguments on the main script. Now we can also return values to the caller function, which is the main script. And we get that -1 right there. Now the variable scope is pretty much what you will expect from a C program. Variables declared here are global variables. So it means they can be accessed through the script and through the function. If we declare a variable like this inside the function, it's still going to be a global variable unless we type a local here. And for example, here we define a preamble variable below. And if we try and print a variable outside that function, we shouldn't be able to see anything. And in fact, it's empty because that it's going to be the scope of that variable is going to be local to this function. We can also define arrays. So let's get some special indexes for the array. And array indexing works the same way as any other language. Got 0, got 1, and we got all the elements. Got the array length. We can also add an element to the array dynamically. Plus or equal Now we can content, and we can loop through all the elements with for f in. Another interesting concept is an associative array, and you might know them as dictionaries. Well, we can declare an associative array like this, where we can assign keys and values here. And we can access the values pretty much as any normal array by key. You get all keys for the dictionary. This we can also loop through the keys the same way we did for arrays. Now, when it comes to strings, we can perform string substitutions like we can get the length of the string with we can also get substrings with selecting the start index equals 0 to 5. We get the first substring. We can also perform substitutions like this. And we can remove file patterns. We can filter for patterns here. More of this is going to be explained in the text processing and regular expression set lecture. We can transform strings from lower all to uppercase, all to lowercase. You can capitalize the first letter, and here you get everything that is going to come handy in your professional life. We can read files line by line, read them into array, and then loop through the lines. You can also write file. That's pretty easy. We already saw how to do that with IO redirection and pipes. And we can also do file processing, although this is not something that's usually done with bash scripts. It's mostly done through the use of the sed command, and we have a whole lecture dedicated to that.